Hi guys, Audrey here. So we're going to now do this L'Hopital's rule problem involving some trig that's a little bit complicated, largely because of the plugging in. So we know that the first step when we are dealing with trig with L'Hopital's rule is that we need to plug in. So here I have a limit as x approaches pi over 2 from the left of secant x over natural log of the absolute value of cosine x. And I want to plug in to see if I get 0 over 0 or infinity over infinity that will allow me to use L'Hopital's rule. So what I'm looking at here is secant of pi over 2 from the left. Unfortunately, secant is not a button in my calculator. And also, if we think about the table of values that we had, secant is also not on there. So here we actually have to remember our trig identity just to be able to plug in. So here I'll have that this equals to 1 over cosine of pi over 2 from the left. Now, cosine of pi over 2 from the left, that we can put into our calculators, but if we put it into our calculators or our brains, we'll see that it actually gives us 0. And we know that that 0 means either infinity or negative infinity. So I have two options for figuring out which one of those two things this is. And it's actually a little bit challenging. So the options to figure this out are A, I could use a graph. So to determine which infinity, A, we could use a graph. And if you know what the graph of cosine looks like, this is actually pretty straightforward. So cosine looks something like that, where that's pi over 2. So this is saying pi over 2 from the left, which means I'm looking at the left side of pi over 2. And on the left side of pi over 2, I can see that the values are positive. So values on the left side of pi over 2 are positive as they approach 0. Okay, so what that means is what I actually have here is 1 over 0 from the right, which means that I have a positive infinity. I can think of that 0 as being positive. So this is like a 0 plus there. So that's one option. Now the other option is to do what you did in Cal 1, which is to set up a little table and plug in a value close to pi over 2 on the left. Close to pi over 2 on the left. And check if it is positive or negative. So a good way to approach this would be to just plug in pi over 2 on your calculator, get a decimal, and find a value that's close to that. So a value close to pi over 2, so here I can say that pi over 2 is approximately equal to 1.57. So if I'm doing pi over 2 from the left, I could plug in something like 1.5. So again, I'm with radians in my calculator, and I'll do cosine of 1.5. The value is not important to me. The only thing that's important is that sign there. I'll get a positive number. So again, this tells me 1 over 0, where that 0 is a positive 0. So this is all positive. So this gives me a positive infinity. So when we're plugging in, it technically doesn't really matter if it's positive or negative infinity. It could be positive, it could be negative, and it's not going to be a big deal. However, for our final answer, being able to make this conclusion is going to be super important. So we'll see that in just a second. So right now, I just got that when I plug in here, I have infinity on the top. Now let's think about ln of cosine of pi over 2 from the left. So here I will do ln of the absolute value of cosine of pi over 2 from the left. Well, again, we already saw down there using methods A and B that that 0 is from the right. It's also in an absolute value, which means that it's 0 from the right. Absolute value means that definitely we have this as being positive. And we saw up here in the last video that ln of 0 from the right, as we go down, get closer and closer to 0 on the right side of 0, we're going down to negative infinity. So we can see that this is negative infinity. So here I have infinity over negative infinity. It doesn't matter that one is positive and one is negative. It's still the form infinity over infinity, which allows me to use L'Hopital's rule. So L'Hopital's rule says the limit as x approaches pi over 2 from the left, the derivative of the top, so I need to know the derivative of secant is secant x tangent x, over the derivative of the bottom. So the derivative of the bottom here, this is a ln, so we're going to be using our chain rule with ln. So I'll remind you guys of that in just a second. So I put cosine of x on the bottom, and on the top I'll put the derivative of cosine x, which is negative sine x. Perfect. Now here, knowing our trig identities actually makes this really straightforward to look at. I know that sine over cosine is actually equal to tangent. So you're seeing that those trig identities that we used when we were doing integrals are not just important for integrals, they're gonna be important here when we're doing L'Hopital's rule as well, because now I can turn this into a negative tangent x, and I can actually cancel out those tangents. So here what I have is the limit as x approaches pi over 2 from the left of negative secant x, which guess what? We already figured out. So here we kind of had, this was our plugging in step. Here we were plugging in. And then this was our figuring out how to deal with the 1 over 0 step that we ended up having to use at the end here, because secant of pi over 2 from the left, we already figured out was that positive infinity right here. So this means this is negative 1 times positive infinity, and the answer here is actually negative infinity. Negative infinity. So that is our final answer. And I just want to remind you guys before we look at some other problems that natural log of a function, so ln of a function, if I want to take the derivative of that, then I do the derivative of the inside function divided by the function itself. So that's what I did up here when I did the derivative of ln of cosine. All right, so these trig problems can be quite challenging, and it really is going to be important to be comfortable with those trig identities. I do want to make one last point though, which is that we started off by figuring out that secant was positive infinity, but I don't need to know that to do L'Hopital's rule. The sign doesn't matter. So the signs of infinity do not matter in order to do L'Hopital's rule. And so what that means is we only need to find the signs if infinity is the final answer. The final answer. All right, so that's it for this video. In the next video, we're going to see that sometimes we can use L'Hopital's rule multiple times. That's all. Bye, guys. Bye.